Hello everyone, this is Official Sando. Today I'm going to talk about some knowledge about Dataframe and how to implement partitioning patterns by using PySpark. If you like my videos, you can support me by subscribing my channel and also liking the video. You can find the complete code for the examples I introduce in the videos and also the complete video list in video description below. Okay, so what's data frame? The data frame is a table with name columns, which induced by pandas library. We represent all the data in a dictionaries type in the data frames. So the hash key for the dictionary is column names, and the data is we call it series. And each series represents a column. Also, R has a similar data frame type. PySpark support both RDD and the data frame. And here it shows the performance test they are doing to compare with RDD and PySpark by using different programming language. From this chart, we observe that the performance of data frame is better than RDD. Now, you may have questioned that why we still want to use RDD over than data frame. So in one blog post from Databreak, they basically describe the answers. When you can use RDD when you want low-level transformation and actions and control on your dataset. If your data is unstructured, you can consider to use RDD as well. If you want to manipulate your data with functional programming constructor, then domain-specific expression. So this part, it shows basically you can more easier to pass in your lambda functions to do any operations as what we do in previous videos. If you don't care about imposing a schema, such as columnar format, which is exactly the data frame. Also, if you can ignore the optimization and performance benefits bring from data frame, you can choose RDD. So next sections, I'm going to introduce partitioning pattern. This pattern is to move the records into categories, but doesn't really care about the order of records. There are several applications to use this pattern. Partition pruning by continuous value. So say if your data has a value range from 0 to 20, you can partition them into several sections. For example, 0 to 5 as a one partition, and 6 to 20 as a second partition. You can partition by continuous value or discrete values such as category. For example, if you have records has a columns, say countries, you can partition by countries. Or if you have columns named as state, you can also partition by state. Sharding means if you have state the data into the different disks or different hardwares, you also need to partition your data. So in these videos, I'm going to talk about partition records by countries. So to suit for my theme for the first sections, I'm going to generate my data based on the data frame. This is a difference compared with my previous video. Generate data in data frame in PySpark is also very convenient. So first you need to define data, that is each columns, and also you need to define the schema, which is each column head. example, the name here respond to my first column, and the country here respond to my second column. Then you pass the data and the schema to Spark, can generate data frame. However, for later operation to implement the partitional pattern, I want to implement my customized functions. So I feel the RDD ways is more convenient to do that. So here I will transfer the data frame to RDD. In my later videos, I probably show more regular operations done for the data frame. So now we have the whole RDDs contain the data. So now we want to partition the data by country. As you may see here, we have two countries here. One is Japan and one is US. And one interesting thing for this data is that we have much more US than the Japan, which is bring some post-processing we need to do in the later. First steps, I'm going to map each records by its country, which is one, and with the whole record. Now here, I define the final partition I want to have is 3. Why is 3? Also, we only have 2 countries, but I noticed that the country with US has much more records. So here I want to put almost the same numbers of records in each partition. So I choose to also separate the US records into 2 partitions. So Japan has 1 and the US has 2. So here I have 3 partitions defined. Now I'm going to use partition by PySpark building functions to partition. First argument is the total number of the partition I want to partition, and also my cost functions to partition. And here is how is the magic happening. So partitional function take a key, then basically the key we are doing the mapping, and we need to return the partitional group we want this record go into. So I will go put the Japans into the third third partition, and for US I'm going to randomly choose from 1 and 2. Then below answer is after I partition RDD. For this run, you can see the US and Japan has been totally separated, recorded by each partitions. And we equally have the similar number of records for US in the second and third partition. This is great, right? So, but here we still have some partitional issues here. When I previously mentioned, we have much more US data than Japan data. Then for this kind of data set, we call this skewed data. The data has a long tail on one side of the other. Then what happens here? Before I trying to use random to random shuffle from the US to the first and the second partition. Then the problem is that for very small data set, this kind of shuffle is not evenly. So here I rerun the same code. You can see the problem is that at this time, the third partition only have 1 US record, but the second has 5 records. So this is the commonest problems in the school data. I'm not going to talk about more what's the best solution for this. It's better to leave you to think about these problems offline. Then, yeah, that's all the topics I want to talk today. If you have any question or comments, please leave them under the videos. I'll see you in the next video.